Hi guys, so week 4 starts tomorrow, and so I wanted to give you an introduction to what we're going to be talking about, and then show you some technology that's going to be helpful. So tomorrow, week 4, we're going to be talking about parametric and polar coordinates. So parametric equations and polar coordinates, these are different ways to write equations so that they're not in terms of x and y, and a lot of times these can make things easier to integrate, especially if you have things that are circles, spheres, curves. So it's really important to know how to do these because it will make your life easier. So Desmos can graph these, and you're going to be doing a lot of graphing this week. So I want to show you how to use Desmos to do polar coordinates and to do parametric equations. Okay, so I have Desmos up here, and so this is our normal XY in rectangular coordinates. And so polar coordinates, these are things that are in terms of a radius and then an angle. So that's why they're really useful for circles. If you go to the graph settings on the right, it has this choice for grid. So it defaults to a rectangular grid, but if you click on the circular one, this is how you do polar coordinates. So polar coordinates is all a radius and a circle, and then you would choose radians or degrees. We always do things in radians. So an example, so that's how you can graph it. Now, actually, Desmos has some examples to show you how this works. So I'm going to open those up. So if I open up my tab, I've got a whole bunch of saved graphs. We don't care, but what we care about is these examples. So here, so polar coordinate rows. So polar coordinates, as I said, they make things with circles. So here's an example of what it could look like. So polar coordinates, you write your equations in terms of r and then theta. And then you can make your theta go from, let's say, 0 to 2 pi. And then you can see, okay, if I graph it across, that is my input variable, it forms this curve. So I could then make it 4 pi and 6 pi. And you can see the curve keeps going because the way parametric or polar coordinates keep going is that once you complete a curve, that doesn't mean it's always done. So sometimes it kind of makes these little circles. And so you want to keep increasing until you don't see any new circles, basically. Because a lot of times what people do is they start graphing these polar coordinates and they go from 0 to 2 pi, but that's not the period. The period is much larger. And so you want to keep graphing over increasing theta until you start getting repetition here. So you write your equations in terms of r and theta. I'm going to open another one here, the logarithmic spiral. So again, this is in terms of r and theta. This goes to 12 pi. This is one that never repeats. So if I only went to 2 pi, you can't really see anything. I have to zoom in. See a little tiny spiral. This one, because it keeps getting bigger and bigger and bigger, it never repeats. So you have to actually have an input range that you're looking at when you graph something like that. And then we've got polar coordinates conic sections. We're going to be talking about a lot of conic sections, which is something that you saw pre-calc. We talked about conic sections. So we're going to be revisiting those. So here is a conic section, and then you can see that on the polar graph. And again, your equation is in terms of r and theta. The other thing we're talking about are parametric equations. So parametric equations are basically, instead of having your input as x, you're using t for time. So I'm going to open up parametric. So parametric is on an xy graph, but our input is t instead. And so it's as time goes by, your graph starts doing interesting things. So this just gives you a little introduction. So it's just you use t. And a lot of times we're using sine and cosine instead of. So it's like a combination of sort of doing polar where you've got your unit circle, but then you're doing t instead. So it's sort of half polar, half rectangular. There's a cycloid. So this is a really neat animation. So you can see it's actually, you can do animations in Desmos, but your graph is in terms of t, and then you've got a sine and cosine. So it's making curves, but our input variable is time instead. And then, so that's the blue that you see is a parametric equation is also, it could start looping over itself, sort of like a polar coordinate. So when you're doing your work this week, Desmos is going to be really handy for graphing these and making sure what you have is correct. And then I'm going to just pause that for now. If you want to put these in your Word document, so there's a little share button. And so when I click that, you can export the image, and then you can choose what size, and then it downloads the image. And then you can even copy and paste the image into your Word document. So that will be really helpful this week. So explore that. And I think that's all I've got. My only other reminder is to make sure that you are turning in all your work. I know I've got a lot of people that are still missing assignments, so make sure you get those in. And I will try to grade all the late assignments as soon as I can, but my priority is always the assignments that are turned in on time. And check feedback. If I ask you to resubmit, go ahead and resubmit. That will increase your grade. So if you have any questions, let me know. And I will talk to you guys later.